So the dot point we're looking at is this one here. So can I also make sure you mark it out that the day we did it was on the 26th of March. We're going to look at the molarity formula, and we are going to also look at dilutions. If you want to look at your textbook reference, it's page 173 to 191. This is what our lesson intention is, and this will be our success criteria. So what you need to do by the end of the lesson. So here we have a little simulation. I'm not going to play it on just because it does disconnect the connection. But we're essentially saying concentration of something is where you have, let's say we have bits of salt, and we're going to have it drop down into the solution here. When we have some kind of solute in a solvent, there is a change in our concentration. Let's just imagine it to be 0.5 moles per liter. Okay, so that's what we're essentially saying. Concentration, in this case, moles per liter. How many individual particles is there per a liter of solvent we have? This is the overall formula. So we say concentration, in this case, molarity of a solution in moles per liter indicates the number of moles of solute dissolved in a liter of solution. So remember, number of moles is just a quantity, so a quantity of particles, a counting number of how many particles we have in a liter of solvent. And to calculate that, it's the number of moles of solute given in moles over the volume of solution. So C equals N over V. V is the volume, N is the number of moles. Don't forget, in chemistry, we actually solve things in terms of volume per liter. So L minus 1 is the same as dash L. Okay? It's just a fraction. If you want to find the number of moles in a solution, so number of moles of the solute, it's the molarity, capital C, times the volume of the solution. So all I've done is I've moved V over onto this side, I've multiplied it, so I've moved it towards this side, and that's essentially how I get this formula here. So we need to try some calculation questions. So calculate the molar concentration of a solute that contains this amount of moles of potassium nitrate dissolved in 200 milliliters of solution. So if I do that, actually I'll do this one at the bottom here just because it has a bit more space. So calculate the amount in moles of the concentration. So I know that the number of moles of ammonia would be equal to our concentration, would be equal to the concentration of NH3 times the volume, NH3. Okay? The concentration is 0.3277. Notice that the volume is 25 milliliters. We need to convert that into liters. So you do divide it by 1,000. Another way of doing that is just say 25 times 10 to the minus 3. If I grab my calculator and do the calculations here, I'll find that my overall answer should be roughly 0.00825. If I just change that into the appropriate scientific notation and sig figs, as you can see in our question, 25.0 is 3 significant figures. It's the smallest one in the question, so we can write it out like that. So 3 sig figs times minus, because we are moving the decimals back, 1, 2, 3, that. And don't forget your units, which is in moles. If I want to look at the concentration up here, concentration of KNO3 equals to the number of moles of the solute. So firstly, the number of moles of solute, 0.105 over the volume, converting that into liters. And we get an answer of 0.525 moles per liter. Okay, so in terms of just going through what these mean. So molarity of a solution is the number of moles a solute per liter of solution. Basically saying, when we say molarity, it means how many moles per liter of solution we have. So that's what we have. If we want to find the number of moles in a solution, based off that equation, you just reverse it. That we've already talked about. If I then want to work out what the mass of my solute is, then you'd have to go back to an equation we did earlier in the term. N equals M over MM. Remember, little m is the mass used up in the experiment, and MM is the molar mass. If you want to work out the molar mass of any compound or element, go to periodic table. Okay. So the next question we have here is question 3. I'm going to go through just one of these because I am short of time for this recording. So it says we have 17.54 grams of barium hydroxide. Barium hydroxide is this formula. Don't forget barium is 2+, hydroxide is -1, so it should look like this. And N bracket that. I want to find the mass there is firstly. So the mass, M, that's this M here. Make sure you label it. 17.54 grams over our molar mass. So if you, this is where you need your periodic table, as I hope most of you do. So barium, there's 1 barium. I have 2 oxygens because of this 2 over here. So there's 2 oxygens, and I also have 2 hydrogens. So I have overall 171.316 grams. If I then plug that into my calculator, 0.102383 and so forth there. Remember, don't round off until the very end. So I'll just leave that there for now. The last thing I need to do is work out the molarity. So moles per liter. So the concentration of barium hydroxide is equal to the number of moles, 0. that, over the volume provided. This one's already converted to for you in liters. And so I have 0.204. As we can see that 3 sig figs is the smallest unit. I can round that, the actual answer, I'll just write it up here. is that, as we can see, 4 can be rounded off to 5, so moles per liter for that. And those are the answers on the other side as well. So question 4 is just the reverse of question 3. And you're trying to find mass in that question. Just a couple more practices for you. So if you want to have a go at this now, I suggest you pause the video. And now I'll go through those answers there. Those are the answers. And moving on next. Okay, the next thing is we know that a lot of things come in different concentrations. And generally speaking, none of the things that you ever come across as a household item would ever be, how do you call it, super concentrated. Generally, they'll actually dilute it. And so here's a video to go through the dilution process. Okay, I suggest you go through the PowerPoint slides, open that PowerPoint slide and go through that video of how a standard solution works. But simply put, a dilution works in a very simple way. What we have here is called a volumetric flask. I'll just change that color to make it a little bit more visible. So we have a volumetric flask. And essentially, you do 4 steps. To make a standard solution, an accurate concentration of any solute, you measure the solute on an electronic balance, transfer that onto your volumetric flask. You're going to dissolve it with distilled water, and then you're going to fill the mass to the marked line. So there's going to be a marked line here. And to make sure it's accurate, the meniscus of the solvent that you use, which is water, the meniscus should just touch that mark there. And that would ensure that you get it very close to, let's say, for example, this was 250 milliliters, and you make it very close to 250 milliliters there. Okay, these are all the relevant steps you need to partake in to make it possible. So, firstly, you need to record the mass onto the electronic balance. Generally speaking, we will tell you what concentration you need to make, so you can work backwards using the concentration formula to get this all done here. So if you want to work out so firstly what you need to do is calculate the mass. Then you transfer the mass into the volumetric flask. You then, using the beaker or whatever you use to measure the mass, you're going to wash it with distilled water and drain it through. The reason why we're doing this is just in case if there's any bits of powder left over or any granite, so just wash it through like that. Preparing a standard solution is a very accurate process, or needs to be a very accurate process, so you need to do your due steps to ensure everything that you've calculated or measured goes into the solution. What you do then is put a bottle cap on top, or actually you don't do that just yet. So you have this little cap on top. Make sure you dissolve the solids evenly in the liquid. You can just inverse it around, and then you pour it up to where the marked line is. So how to prepare a standard solution. So these are the steps. I'm going to go through it right now. And if you hear the bell ringing, well, unfortunate. So we have to calculate the concentration of silver nitrate. It's given in milligrams. So milligrams, 1 gram is equal to 1,000 milligrams. So just to finish off this calculation, so the volume is 0.150 liters. The mass is 16.8 over 1000. You can also write that in terms of 16.8 times 10 to the minus 3 because it's milligrams, and that's the grams you need. Now to find the number of moles, 16.8 over the molar mass. So you need to work out what the mass of silver and nitrate is. So I have 1 nitrate, 3 oxygens, and I have 1 silver atom. Okay? If I do the relevant substitution onto my calculator, I get 0.09887587546. If I then want to work out the calculation of my dilution or my standard solution that I've created, just substitute the number of moles you found in the question above over the volume. And we found that the volume is 0.15 liters. And so the concentration is 0.6, 3 significant figures, so 60 moles per liter. And that's how you would go through to try and calculate the concentration of the standard solution you have created. In the next video, I'll go through dilutions, but just stick with these contents for now. Have a go at the practice questions for molarity and then how to prepare a standard solution.